Hey everyone, this week I want to talk about something that will hopefully help you in your coding journey. So many times new developers will find that they can read through some code, some simple code, right? And they can kind of understand what's going on. But when they're asked to actually write some code, they're given requirements and they have to make the code that satisfies the requirements, they don't know where to begin. So I want to talk to you about that today. I want to talk to you about how you can translate program requirements into code, more specifically into logic. So I'm probably not going to be doing any writing of code, any actual code, but instead I just kind of want to talk about how you can map out the logic of the program requirements, and then once you have that done, you can convert that into your desired programming language. So first of all, it's important to understand that writing code is really just writing out specific steps to solve a problem. Okay, so let's imagine that someone asked you for your famous chocolate chip cookie recipe. Okay, now to make your cookies as well as you do, you have to follow a very specific set of steps and in the correct order, right? If you try to put the chocolate chips in after you bake the cookies, they're not going to turn out right. Or if you add too much of one ingredient, not enough of another, so on and so forth. If you're doing them out of the steps out of order, that can also cause problems. So you begin to write out the steps to bake the perfect chocolate chip cookies, also known as a recipe, right? And writing code is really just the same thing. It's writing a recipe. And just like your recipe, if you do the steps out of order, you're going to get wrong output, or you're going to get the wrong answer. So before we begin working through some examples, I want to tell you something and just kind of give you the general idea that I'm going to be banging into your head today. Almost every single program in existence has the same three main steps, okay? Now these steps can be out of order, or in different orders rather. They can be repeated, but they're all still there. And the reason I say almost every program is because there are some out there that may not have one of these steps, but those programs are not very practical. They're usually just for instructional purposes. For example, the Hello World program that you always learn as soon as you pick up a new language does not fall under this category. But basically these steps are input, processing, and output. Okay, like I said, they can be repeated, they can be in different orders, but those three steps are the ones that I really want you to think about every time that you need to write code from requirements. Now, input can mean a number of different things. Okay, input can come from the keyboard, it can come from a file, the mouse, a microphone, a light sensor, I should say. Also, processing can be done in many different ways, right? You may calculate things, you may parse input, processing text, translating things, and so on and so forth. Whatever the actual program is supposed to do, that's typically the processing. Output, as you may have guessed, can also be a lot of different things. Output can get printed to a computer screen. It can be output to a printer, an actual printer that prints it out on a sheet of paper. Output can be writing information to a file. It can be sound through speakers, a blinking light. You get the idea. But these three main steps are still always used. Okay, now try to think of any program that you use regularly and imagine at a very high level, okay, how does it get the input? What is the processing? What kind of processing does it do once it has the input? And then how does it give you your output? Are there multiple ways it gives you output? Maybe you have the option to write it to a file. Maybe you have the option to print it on your printer, different things like that. So now let's actually start working on some examples. Okay, these examples, they may remind you of like your math class, right, in middle school when you had to do word problems. But hopefully this will be a little more fun. But if you remember, you were always, the task of that was to figure out what you were given, what you knew, basically, what you had to calculate, and then you had to choose the correct formula to solve it, right? The steps in order to solve the problem. So we're going to do almost the same thing, but we're going to just come up with the steps to solve the problem and satisfy the requirements. And then the computer is going to be able to do it for us. All right, so the first example is going to be this. Write a program that will calculate an 18% tip on top of the cost of the bill. Print the tip amount and the total cost, including the 18% tip. So how do we start? What do we do first, right? That's typically the first response you'll get. You'll look at this and you know kind of what how to do it by hand, but where do you start in order to write the code? Let's try to pinpoint each of those three main steps that I was just talking about earlier, okay? So to do that, I'll usually create some comments, and you can do this in whatever language you're using. I'm going to use the double slashes because everyone's used in several languages. But I'm going to put those steps in here. So we have input, we have processing, and we have output. So now let's go back and read through the requirements. Write a program, okay, that's what we're doing, so we can kind of ignore that, that will calculate an 18% tip on top of the total cost of the bill. All right, well, hey, I think that is something that we can use, right? Calculate an 18% tip. What does that sound like to you? To me, it sounds like processing. So I'm going to just paste it right down here. Let's see, next we have print the tip amount and the total cost, including the 18% tip. Well, that right there says the word print, so to me that sounds like output. Now all that's missing is we don't have anything in the input section. So what is the input? What do we do now? Well, let's think about this, okay? What are we calculating? We're calculating an 18% tip on top of the total cost of the bill. Well, we don't actually have, we're not given that value, so we can assume that that's going to come in as input. So I'm going to actually, we'll leave that there. So I'm going to paste that up here then. Okay, so we actually have all three of our steps. So we know what the input needs to be, some bill, right? We know what we need to do in order to process that input, calculate an 18% tip. And then we also know what we need to output, both the tip amount and the total cost of the bill, including the tip. Now, just because we have all the right steps, if we were to do them in the wrong order, we still wouldn't get the right answer. So making sure that the steps are in the correct order is also important. All right? In this case, most of the time, this order will be the same: input, processing, and output. But not always. It just depends on your logic, your program, what you need to do. So how do we get the input? Well, first thing to do is probably to tell the user that we want some input. So step number one will actually kind of be a form of output, right? But I'll group this into the input just because it's necessary in order to get the input. So in whatever language you're using, right, you're going to do some print statement in order to ask the user. You can also call this a prompt, right? So we want to prompt the user for some value, right? For the total cost of the bill. Right? And that will be handled based on whatever language you're using. I'm just writing this out in like pseudocode, just because I just want to talk about the logic. This is not just a specific to any programming language, because you'll do these same steps in any programming language, whatever you're using. Now, a prompt can be a message that is displayed in like a console window if you write little console applications. A prompt could also be a user interface that has a label saying total cost of bill and the text box where they enter the amount. It could even, if you really wanted it to be, could be an audio cue or something that plays through a speaker and says, please enter input, or whatever you want it to do. But whatever it is, we need to get the input. So in this case, I'm just going to tell it to prompt for the input. All right. Now we need to actually retrieve the input, right? We're telling them, hey, enter some value. Then they're going to enter it. So now we need to read it. So I'm just going to type it, I don't know, get bill from input. Call that bill amount. All right, and that pretty much takes care of our input. Right now, it also may be worth noting, okay, you may need to ensure that the input is the correct data type. Okay, so this bill value is going to be used for math, right? We're going to need to do some math on it. So it needs to be a numeric data type. So what happens if they type in, I don't know, the word $100 or whatever, you know? Or they type in ASDF or whatever. In that case, we can't do math on those because they're letters. I'm not going to do it in here, but keep that in mind, okay? As you're working through, you may need to validate your input depending on the requirements of the program. And if you don't validate your input, then there's a possibility that the program can crash. You could even, if you want to, and you know what, I'll do this. Validate input. However that works is up to you. We're going to leave this very high level. That can be broken down into multiple steps, but we're going to leave it just like that. All right. Now, at this point, we're going to assume, hey, we've gotten our input and they entered it in the correct data type, all that good stuff. So now let's move on to our processing step. So I'm going to come down here onto these comments just so that they're kind of easier for me to visualize where each piece happens. So this step can also be broken down further, right? We need to calculate an 18% tip on top of the total cost of the bill, right? And then we need to add that to the original cost of the bill so that we get a grand total, a total, if you will. First thing I'm going to do is I'm going to create a variable that's going to hold the tip amount, okay? We can create as many variables as you need. Try not to duplicate the data, but I'm going to create a variable. We're going to call it tip, assign tip amount. You can call it whatever you want that makes sense to you. To me, tip amount makes sense. Now we need to assign this value to be equal to whatever the total cost is. So cost of bill multiplied by 18%. All right, and for those of you who are familiar with percentages, this is the same as 0.18, which is actually how you would have to multiply it in a programming language, because you can't just write 18%, and at least not in the programming languages I'm familiar with. You actually have to use a decimal value. So 18% in decimal is 0.18. Okay, so that's going to calculate this value and assign it to our variable called tip amount. Awesome. Next, we need another variable that's going to hold the total value, including the tip. Let's do that. We're going to do assign total value. And we're going to assign it the value of, well, how do we do this? We have to add the value of the cost of the bill plus the tip amount. Okay, so we'll do cost of bill added to tip amount. All right. So now we've got that value here assigned into my total value. So now our processing is pretty much done as well. We've gotten two of the main steps done, input and processing. Now all that's left to do is output the values that we calculated. So let's look back up here. We're asked to, or down here, I guess, print the tip amount and the total cost, including the 18% tip. All right, cool. This is really probably the simplest part of whatever program is the output. So we'll just do a couple print statements. So print the value of the tip amount. And if you want to, you can do something maybe like the tip, or you know what, let's do this. 18% tip is plus the tip amount, right? And then we can do that. Another print statement. Total including tip is plus, well, the total value. All right. So there you have it. We have just worked through the logic here and gone through each of the main three steps: the input, the processing, and the output. Okay. Hopefully that made sense to you and you're able to follow along. Now you can take this logic and convert it to whatever programming language you want, whether that be Python or Java, C#, COBOL, whatever you want to use. All right, so let's look at another example. A teacher wants to be able to enter all of the grades for an exam and calculate the average score of the grades entered. Write a program that will continue to ask the teacher to enter a score or cue to stop. After the teacher stops, the program should calculate the average score and display it to the screen. So remember our steps. Let's do input, processing, and output. All right, and let's go back through here. So a teacher wants to be able to convert, that's just kind of telling us what we're doing, right? Enter all the grades and get it. All right, so here it is. Here's our main requirements. Write a program that will, yeah, I know, okay, we don't need to really worry about that. Continue to ask the teacher. Okay, this continue is going to be important, but first, let's see. Ask the teacher to enter a score or cue to stop. So to me, that sounds like input. After the teacher stops, the program should calculate the average score. That sounds like processing. And display it to the screen. That sounds like output. So there we have it. We've got it kind of broken down into our different steps. Now we can break down each of those further. So let's think about this real quick. So where do we begin? Okay, once again, that question comes up. Now usually you want to start with the input, right? So when we're getting our input, it needs to be stored somewhere. In this example, we need to collect multiple values for the input, right? They could enter 36 different grades. So a single variable is probably not going to work for us. We need some sort of a collection of variables, a list, an array, right? Depending on which language you're using. So let's create that list that's going to hold all the grades. And I'm just going to call it grades. Typically, I like to do that at the top before any of the real meat of the program begins. That way, all my declarations that I'm going to need are declared in one spot, and I know where I need to go to change them or add more or remove some. So we're going to assign the value of an empty list to my grades list, right? Array, however it translates into your language. Now we can start our loop. This can also be tricky because we have the word continue, right? Continue or until. So if this were written as write a program to ask the teacher to enter a score until they enter cue to stop, that's another way it could have been written. But when you see those words continue or until, you typically know that you need to do a loop, right? And if you're not familiar with a loop structure, it's really just a section of code that repeats until a certain condition is met. So now we can start our loop that we have, now that we have our variable that's going to store all the values. So the requirements tell us to continue to ask until the teacher types a Q. The way I like to do these, okay, when you have these types of prompts, is to actually start with something like this, right? While some condition, and I'm just going to do while true. Okay, now I know what you're thinking, right? Hey, now that's an infinite loop. Aren't infinite loops bad? Well, yes, they are, okay, usually. In this case, we want to loop indefinitely because we don't know how many times the teacher is going to enter a score. Now, indefinitely is pretty close to infinite. So we make this infinite loop, and then we can end it on the inside, which is going to then make it so it's not an infinite loop. So the first step of our loop is to tell the user we want some input. So that comes back into the prompt like we saw before, prompt for input, and then we need to read the input. So I'm going to do assign input from user, however you want to do that. All right. So we've got our input. Now we need to check that input to see if it's the quit value. So we'll make a quick decision. If the input value is the Q to quit, then what we need to do is exit the loop. So at this point, now it is no longer an infinite loop because we have the possibility to exit the loop. So that's the way I like to do it. It kind of just makes things a little simpler, easier to read and write. All right, but if they did not enter a Q, then it's going to skip this line and not exit the loop, and then we are right here. So if they don't enter a Q, then what we need to do is add that input into our grades, the grades list, right? Add input val to grades list. All right, now again, you may want to validate your input before you add it because you are going to need to do math on it. But for now, I'm going to assume that this teacher enters everything in exactly correct. So there we have it, and that takes care of our input. As long as this is true, it is going to do this, and it's going to prompt for input. It's going to then assign that into this variable, whatever the user enters. If they enter a Q to quit, then we exit the loop, right? Then we jump down here and begin our processing. But if they don't enter a Q, then it skips line 15, and it's going to go down here and add the value to the grades list. Okay, now this is where the loop is kind of interesting. As soon as it gets to the end, it's going to jump back up to the top and do this all over again. So that takes care of our input. Now, after we have all our input, we need to do the processing. So that's where we get right here. So how are we supposed to process this? Well, after the teacher stops, okay, which it says right here, after the teacher stops, the program should calculate the average score and display it to the screen. Okay, so how do we calculate an average? Well, we need two things for an average. We need the sum of all the values and the total number of values that were summed. Now, most languages have built-in functions to help with this step, okay? So I'll leave that to you to learn how to do that. I'm just going to write here, assign sum of grades equal to sum grades list. Okay, something to that effect. And then we're going to assign count of grades equals to length of grades list. Something to that effect. So this, once again, I'll let you figure out how to do that in your language. There are typically some simple ways to do that. A quick Google search should help you with that. So now that we've got the sum of the grades, we've got the count of the grades, now we can assign the average to be whatever the sum is divided by the count. Now, again, it may be worth validating here, right? Validate count of grades because you want to make sure it's not 0 because you can't divide by 0. If you do, your program is going to crash. So that may be worth entering there. Then we assign the average to be, well, the sum of the grades divided by the count of the grades. And there we have it. So now our processing is complete. We have gotten all the input, we have gone through each of them, added everything up, counted the total number of elements, and then we have also calculated our average by taking the sum of all the grades and dividing by the number of grades that were entered. Now all that's left to do is to display it to the screen. That's the output here. This should be pretty easy to you, right? Print the average grade is, and then whatever the average is. So there's a couple examples for you. We were able to take those requirements, break them down into 3 main steps, the input, the processing, and the output, and then each of those were able to be broken down even further until they were manageable. And again, every program, virtually every program, has these same 3 high-level steps, okay? The input, the processing, and the output. So if there's one thing you take away from this, it is input, processing, output. And it's just a matter of breaking each of those steps down further and further and continually until you get to something that is manageable and easy to write. Now, as a bonus, here are a few keywords to keep in mind when reading requirements and how to translate them into the high-level logic. For input, getting input, you may see things like ask, right? Ask the user for this value, or have the user enter something, or get a certain number, get a certain value, right? Retrieve the answer, read from a file, given some number. That's typically your input. So these values will kind of indicate that you need to get input. Okay, so if you're reading through your requirements and you hear one of these keywords, automatically start thinking, that's where I'm getting input. And you may get multiple inputs, right? You may get just one, you may get multiples. So keep that in mind. Some keywords for processing may include calculate, right? Calculate the answer. Parse the text that was entered and determine how many times they did this or that, right? Find some value, find some result. Determine, I think I said that when I was talking about parsing. Determine what the answer is, right? Process, you may see the word process, right? Process each value that was entered and do it this way. Convert everything from this to that. If you hear one of these keywords, then start thinking, okay, this is processing, and then start trying to break that down further and into the manageable steps. Once again, here's some more keywords for the output section. You may see things along the lines of display to the user or something, right? Print to the screen, output this value. They may actually use the word output. Show what the result is. Provide an answer, right? Provide the resulting calculation or something to that effect. So those are some keywords that you can think of or keep an eye out for, and that typically will mean output. Now again, okay, these steps, they can be repeated. You may get input, and then you may process it, and then you may get more input based on that processing, and then do some more processing, and then at the very end you'll have output. Or you may input and then output a couple things, and then there's an infinite number of ways that these can be used, but they all exist, right? They're all there in pretty much every single program. Now into some more of the logical keywords. You may see things like if, right? That means you need to make a decision. Use the if-else structure. Determine if, in the case or in the condition of this, then do that, right? You may get otherwise. That typically means else. Instead. So do this in this condition, or do this instead, right? However, if that is not the case, then do this. That would be an else block, right? An else section. Now with loops, I mentioned this just a little bit ago in our example. You may have words like continue or while, until, for each, in a range, or for each value, right? Do something. Those indicate that you need to loop. A few keywords that may indicate you need to do math, right? Some addition, add, sum, right? Total, more, combined. I know these ones you should have learned a long time ago in middle school and stuff, but hopefully this may help out a little bit if necessary, right? For subtraction, you may have subtract, difference, right? Less, under. For multiplication, you may have the word multiply, or the product, or times, right? This times that. And finally, division. You may have the word divide, or quotient, out of, right? 17 out of 30. Fractions, 1/8, over, right? Like over the period of time. That may indicate division. So these are just, most of these I'm sure you already know, but this is just kind of a refresher and just to trigger that in your memory. Every time you hear these types of words, start thinking along these lines, right? These ones will be used mostly in the processing section, because that's typically where you'll do calculations. I hope this really helped you. I hope you can see how even a very complex set of requirements can be broken down into manageable steps, right? Starting with those first three, input, processing, and output. And you can use them over and over as many times as you need, and then break each of those down even further into something that is just a little bit more manageable, something that comes a little more naturally to you. And that's it. That's the entire process of writing code. Now you can go write your own amazing applications, just given some requirements. So have at it. Happy coding, guys. Thanks for watching.